Welcome to T3 Day 6 of Calculus. Today we're going to talk about the interpretation of the definite integral. A definite integral is an integral that has limits of integration. Those are these two numbers, the 0 and the 5 in this case, the a and the b value. So if there are actual numbers there, you'd call this a definite integral. Yes, if there are no numbers, it's called an indefinite integral. We're not looking at those quite yet. So we're given a velocity function, and we're told it's in feet per second. And remember here, it's asking to evaluate and interpret each of the following exactly. So v of 5 just means plug 5 into the velocity function. So that's 5 times 5 plus 10. Well, that's going to be 25 plus 10, which is 35. And we know velocity, because the question tells us, is in feet per second. So this is the velocity of the person after 5 seconds. This is asking for the area under the curve of the velocity function. So that's going to be the net distance traveled. The net distance traveled. This is not necessarily the distance traveled, because the net distance traveled is the change between where you are right now and where you are at 5 seconds, or the change between where you are at 0 seconds, this person, and where the person is at 5 seconds. What I mean by that is you could go 1,000 miles up and 1,000 miles down, and the net change would be 0, but your total distance traveled would be 2,000. So in this case, this is the net change, the net change in position. So how do you find this exactly? Well, this is a linear function, so you can actually do this by hand. And you know it's 5t plus 10. So that's going to have a y-intercept of 10 and a slope of 5. And it's going all the way to 5, because we're going from 0 to 5 right there. So it's just asking for the area here underneath this shape right here. And you can do that by hand. How do you do that? We'll break it up into a rectangle and a triangle. The area in that rectangle is going to be base times height, so that's going to be 5 times 10. And this triangle, so that's 50. And this triangle right here is going to be 1/2. The base is 5. And what's the height? Well, you need to know that point right there. That point is 5, 35. So what's the height here? So what's the height from here to here? Well, that's from 10 to 35. It's 25. 25 is the height, so that's 125 over 2. So the total area is 50 plus 125 over 2. So that's the net change in position for feet, meaning the person has gone a total of 50 plus 125 over 2 feet. In the next question, we're doing something similar, but this time we're given the rate at which the value of a house is increasing. This is the rate here, where t is in years after 2000 and r of t is in dollars per year. So when we plug 5 into here, we need to use our calculator for this. Please plug the function in as y1. So then quit out to the main screen here, and then do vars, y vars, and we can evaluate it at, let's just do enter there. Excuse me. We do vars, y vars, enter, and then put a 5 in there. We end up with 10,466 point, and you know I like 3 decimal places, 0.446. And that's going to be dollars per year. That's the rate here, meaning the house is increasing at the value of the house is increasing at a rate of $10,466 per year. So this right here would be the net change in price, net change in the price of the house, So how do we do that on our calculator exactly? Well, what you do is you get math and then 9. That's going to bring up this menu, math 9. And you fill in the blanks here, 0 to 5. And then what function are you using? You're using y1, like this. And then you're doing the integral. Oh, sorry, I missed it with respect to x. I'm going to delete that. You press enter, and it's 47,245. 47,245 point, because you know I like 3 decimal places, even if it's in dollars, 724. So that is the net change in price. So the house, that's not the value of the house, but that's how much the value of the house has changed from 2000 to 2005. The net change in price from 2000 to 2005. So these you need to be able to do using your calculator. Now, some people might have a calculator where it looks like this. So if it's on your calculator, you can type this in exactly. You can type that in exactly. Sometimes your calculator might have a different operating system. You need to plug it in like this. So in this case, as long as this is y1 right there, as long as that's y1, if your function does fn int instead of that symbol right there, you first do y1 and then x, and what's the lower one on this? 0, and then 3. You plug it in like that. So how would you find the area between the curve from 0 to 10? Well, you go from 0 to 10 of negative 4x squared plus 64 dx, and you'd use your calculator for this. So how do you go about doing that? Well, first plug it in as y1, so it's negative 4x squared plus 6. So I plugged it in right there. And now you quit out to the main screen. I'm going to clear this. And then it's not var, sorry. It's going to be math 9. We're going to go from 0 to 10. 0 to 10. And remember, you go to vars, y vars, enter, enter. Move your cursor over to x. Oop, I'm going to delete that. That's not supposed to be there. Let's go over to x right there, x, and hit enter. Negative 693 1/3. Negative 693.333. So now you can use your calculator to evaluate definite integrals.